Hi everybody, today's topic we're going to be talking about is compound inequalities. So let's start by looking at a couple of examples of compound inequalities. First off, to avoid turbulence, a pilot must increase his altitude to at least 33,000 feet or decrease his altitude to no more than 26,000 feet. This is an example of a compound inequality. There's actually two inequalities here. We have one here, he needs to be at least 33,000 feet, that's one, and the other is he can be at no more than 26,000 feet. So he can do one of those things or the other. Another example of a compound inequality is this one. In order to have a B average for the quarter, Marty has to score between 86% and 91% on the next test. That means that he needs to have at least 86, but no more than a 91 if he wants to maintain a B average. So these are both examples of compound inequalities. A compound inequality is two inequalities considered together. It's kind of like a compound sentence when you put two, or a compound word, when you put two things together into one. So we're going to be taking two inequalities and putting them together. In order to do that, we're either going to use the word and or the word or. If we use the word and to put the two together, that is known as an intersection. And if we use the word or to put them together, that is known as a union. So we're going to focus on each type separately. Okay, so let's start with an intersection. An intersection is the graph of a compound inequality containing and. The solution is the set of elements common to both. So if we say and, that means that whatever numbers are the solutions have to satisfy both inequalities. So here's a non-numeric example. If we took the set of all the females at Stone, let's say, put them into a group here, and then we took the set of all students who are taking algebra at Stone and put them in a group. There would be some overlap there, and this would be the section that would include students who are female and taking algebra. This is where the intersection of those two groups is. The people have to be both female and in algebra in order to qualify for this. So an intersection is the case where we're looking at the overlap between the two groups. Here's a numeric example. If you think about, you want a number that's greater than -2 and less than 3. So if I wrote that out, I would have x is greater than -2 and x is less than 3. So if you think about it, if we start with talking about all the numbers that are less than -2, I'm sorry, greater than -2, there's a lot of them, like the number 10, 33, 16, I could go on all day here, 5.5, there's lots of numbers greater than -2. And then if I start thinking about what about numbers that are less than 3, well, -10 is less than 3, -33, -16, again, I could keep going like this for a while. But what we're interested in here are numbers that are both. So any number that we could put in the intersection of these two groups, like -1. -1 is greater than -2 and it's less than 3. So is 0. So is 1.3, and so on. So any numbers that are in both groups would be called the intersection of those two groups. So just like we did when we talked about any sort of inequality, we're going to need to be able to graph our solutions for a compound inequality. So it might help to look at what that would look like for an intersection. All right, so again, this intersection is slightly different than the one we had before, but pretty similar. We're going to say, okay, we want numbers that are less than 3 and greater than or equal to -2. Okay, so I definitely need to have my numbers on the number line. So I'm going to start with -3, -2, -1. You should be doing this on your paper too. 0, 1, 2, 3, 4, 5, let's say. Okay, now we're actually going to have to make two different graphs and then put them together into one. So I'm going to start with this one. X is less than 3. Okay, just like we talked about last week, less than is an open dot, and less than would be pointing to the left. Let me change my color here. Then we'd have x is greater than or equal to -2. Okay, well, greater than or equal to, as we talked about last week, that's a closed dot. And then that would be everything going this way. Now, ultimately, what I want to do is I want to put these two together into one graph on this number line. Okay, so I have to think about, we want the intersection of these two. So if I start here at -3, -3 would qualify for the green graph, but not the red graph. And I look at -2. Okay, -2 works for red, and it works for green. So that's going to be included in my final answer. -1 also works for both. So that's going to be included. 0 works for both red and green. 1 works for both red and green. 2 also does. Then we get to 3. Well, 3 would satisfy the red. It is greater than or equal to -2. But it doesn't satisfy the green. It's not less than 3. So that will not be included. Neither will 4, because 4 only fits the red, and neither will 5, because 5 only fits the red. So it's from -2 up to 3, but not including 3. But we are including everything in between. So a lot of times an intersection, especially the ones we're going to focus on this year, will be between numbers that are between two numbers, like the case here. X can be anything between -2 and 3, but not including 3. Okay, I'm going to leave this part for us to do in class. If you'd like to go ahead and solve each of these, you certainly may, or we'll try that in class. Okay, another thing with intersections is that often we can write them as one long statement. Okay, that statement should always be written from least to greatest. We have seen this before when we did domain and range, when domain and range were between two numbers. Okay, so this is what the one long statement would look like. This says that 2 is less than x and x is less than 5. Notice I used the word and in there. I said 2 is less than x and x is less than 5. There's an implied and there because these two statements are connected. Another way to write this one would be to switch that around. We could say x is greater than 2 and x is less than 5. So in order to satisfy this, x has to be between 2 and 5, just as it's written. You may also see this in set notation, as we did back when we did domain and range back in Unit 3. So just as a reminder. Okay, so we're going to try writing these as one long statement. If you'd like, you can pause the video and try this on your own. Okay, first, a number is between 10 and 20. Okay, well, I'm literally going to put the number, I'll use n, between 10 and 20. Okay, well, if it's between 10 and 20, then it's certainly not less than 10. It must be greater than 10. But when I write that here, that's going to look like this. 10 is less than n. And then if it's between 10 and 20, it's certainly not bigger than 20. So it's less than 20. So 10 is less than n, and n is less than 20. Alternately, you could also include the or equal to's, because I didn't specify in my sentence whether or not to include the endpoints. So either with the or equal to's or without them, both would be correct answers. All right, the next one, a number x such that x is less than 3 and x is greater than or equal to -2. If you'd like, you can pause and try this one on your own. All right, if you remember from when we did domain and range, our signs will always be, since we're going from least to greatest, our signs will always be less than signs. So this part's fine. X is less than 3. This part, I want to change it so it's a less than sign. So I'm going to turn this around. So if x is greater than or equal to -2, then -2 is less than or equal to x. All right, now I just have to put this in order from least to greatest, just like I have up here. 10 is less than n is less than 20. That means I'm going to put -2 is less than or equal to x, which is less than or equal to, I'm sorry, not or equal to, just less than, since that's what it says here, 3. So I've really just put this statement here, and then this statement right here. And they put together into one long statement. Okay, we'll also try solving this one in class. Okay, on to unions. Unions are just the opposite of intersections. The union is a graph of a compound inequality containing or, which means the solution is a solution of either inequality, but not necessarily both. So for example, if I said b is less than 7 or b is greater than or equal to 9, well, there's a whole set of numbers that are less than 7. There's a whole set of numbers that are greater than or equal to 9. There is nothing that's in both sets. So an intersection is the overlap of two groups. A union, however, is just the opposite. A union would be anything that's in this group or anything that's in this group. So we're actually including more things. If I want the number to be less than 7 or greater than or equal to 9, I'm including a lot of stuff, not just stuff that fits both, because in fact there is nothing that fits both. A real life example would be, I would like to have a Coke or a Diet Coke. So I don't care which one it is. It can be from either group. I'll take a Coke or a Diet Coke. Okay, so now we're going to try graphing a union. So this one is C is less than 3 or C is greater than or equal to 4. Okay, so this is a little easier actually, but again, I need to start by marking my numbers on my number line. Try to evenly space them. I like to go one number beyond what I need. So this worked out nicely. I went one number lower than -3 and one number higher than 5. Okay, so first of all, C is less than -3. Well, that would be open dot on -3 and going to the left. Or I'll also take numbers for C that are greater than or equal to 4. Well, that would be a closed dot on 4 pointing to the right. And that's it, because this time we're not looking for the overlap. We're not looking at numbers that fit both. It could be either here or here. It doesn't have to be both. So this is what the graph of a union will often look like. It's disjointed or disconnected. This would be like the case where the pilot had to decrease his altitude lower than 26,000 miles or increase it above 33,000. I'm sorry, feet, not miles. That would be a case like that. You can either do this or that and you'll solve the problem. Okay, let's try this one. So this one has fewer numbers involved. So I like to start one number lower than I need. Oh, oops. Oh, that's not right. I need -6. Okay, those are my numbers. So this time, greater than -1. Okay, well that would be here, -1. not including, but everything greater. And G is less than or equal to -5 would be closed dot on -5, everything less. Something to remember about unions is that they cannot be written as one long statement. I cannot write this as one statement. Let's see what happens if I try to. Remember, in one long statement, I want it to go from least to greatest. So the least number I see here is -3. But if I want to put that first, I have to switch this around. So this would say -3 is greater than C. And then I would have C is greater than or equal to 4. Well, let's think about that. -3 has to be greater than C. C has to be greater than or equal to 4. This can't possibly be true. There's an implied and here. Because we're only writing the C once, we're implying that C has to do both these things. And it can't. It's impossible. So you cannot write a union as one long statement like you can for an intersection. Okay, we're going to continue with the rest of this in class. So that's all you need to complete for now, unless you would like to go ahead and solve these inequalities and try graphing them on your own. Otherwise, we will talk about that in class. Thank you for watching.